Hi everyone, thank you for joining us once again. We are still continuing with our grade 12 November 2021 past paper revision. We're going to focus on question 4, which is sequence and series, and this is for arithmetic. Question 4 says consider the linear pattern 5, 7, 9. 4.1 it says determine term 51. Okay, so we know that this is a linear pattern and it's actually an arithmetic sequence. Okay, so we know that the general formula for arithmetic sequence is Tn is equals to a plus n minus 1 d, right? Meaning that if we want term 51, where there is n, we're going to put what? 51 minus 1 multiplied by d. This is the same as a plus 51 minus 1 is 50 d. All right, so we just need the value of a and d and then get term 51. So a, we know that a is the first, it's the same as the first term, right? Which is what? Which is 5 plus 50 into, what is the common difference? We get the common difference by saying the next term subtraction the previous term. So in this case will be 7 minus 5, which will give us 2. Also, if you say 9 minus 7, you must get 2. So this is what is the common difference, d. So we replace by 2, then it's going to be 5 plus 100, which is the same as 105 as our term number 51. All right, let's go to 4.2. Says calculate the sum of the first 51 terms. All right, how can we calculate the sum of the first 51 terms? Obviously, we can't do it manually by going to get all 51 terms and then add them up, right? That will take a lot of time. So we have a simplified formula that helps us to get the sum of an arithmetic sequence, right? So it says Sn is equals to n over 2 into a plus what? Plus last term. All right, so we need the sum of the first 51 terms. So our n is 51 divided by 2. Our a is our first term, which is 5, plus last term in this case will be term number 51 because we need the sum of the first 51 terms, meaning that the last term is in position 51. It's term 51, which we have already calculated in 4.1 to be what? To be 105. So that is our last term. So we'll simply punch a calculator and get the answer. So the answer will be 2805. All right, let's move to 4.3. It says write down the expansion of the sum of n equals to 1 up until 5,000 into 2n plus 3. Show only the first 3 terms and the last term of the expansion, right? They want us to expand this sum, right? So we know that this is sum of arithmetic series, right? Because the general term there, our Tn, is an arithmetic sequence. Okay, it's the general term for arithmetic sequence. So we need to show the first 3 terms, right? So if we expand this, we are going to replace n by 1. So it will be 2 into 1 plus 3. That is our first term. Plus, why are we using plus? Because this is a series, right? We are just adding terms, right? So it's a sum. We are adding terms from n equals to 1 till n equals to 5,000. All right. So the next one will be 2 into, after 1, we are followed by what? By 2 plus 3 plus 2 into 3 plus 3, right? So those are the first 3 terms. Plus, we must show them that now we are going to the last term. So we use those dotted line to show that we are going to the last term, those dots, obviously. So then the last term, we have to replace what? We have to replace n by what? By 5,000. And why by 5,000? Is because we said here down, this is the starting point. We are starting when n equals to 1. And on top is the what? Is the ending. So it's when n equals to 5,000. So that's our last term. So where there is n, we're just going to put 5,000 and plus 3 according to the general formula. Then we can simplify and show them the answer. So it will be 2 plus 3, which is 5, plus this one will be 2 into 2, which is 4 plus 3, which is 7 plus, then we move to the third term, it will be 2 into 3, 6 plus 3, to be 9 plus, we go towards the last term, which is 2 into 5,000 plus 3, which is 1,003. I mean 10,003, right? So that is our last term. So we have actually expanded our sum, showing them the first 3 terms and also what? The last term. Let's lastly conclude with 4.4. It says hence or otherwise calculate that sum plus that sum. All working details must be shown. All right. So the word hence, it's actually meaning the answer that you got in the previous question should assist you to solve this question that is being asked here, right? Meaning that we should use our 4.3 and it should assist us to solve this question. That's the meaning of hence. And every time they use the word hence, they basically mean that, okay, the previous answer must assist you to answer this question. All right. So we know that from the previous question, we were able to expand the first part of this sum, right? Which was this sum here, and we managed to expand it to be 5 plus 7 plus 9 plus up until we reach the last term, which was 10,003. Okay, so now we can also go and expand that one, right? Because you have two sums now. 4999 into minus 2 and minus 1. So when we expand it, it's going to be what? Minus 2 into 1 minus 1, right? You can just put that in brackets, plus minus 2 into what? Into 2 minus 1 plus minus 2 into 3 minus 1, right? Those are the first 3 terms. Then let's go and also get the last term. It's going to be plus minus 2 into the last value here. It's when n is equals to 49999, right? So 4999 minus 1. All right, so we can just simply use a calculator to get the answer of those. All right, when we simplify, it's going to be minus 3 plus minus 5 plus minus 7 plus, and the last term will be minus 9999. Okay, can you see that there's something similar between these two sums, right? So there's this first part of the sum, the second part of the sum. These ones are positive, can you see them? And these ones are quite less the same, but they are actually having an opposite sign, which is negative, right? Can you see that if we take it from here going there, and we take that from there going there, it's quite the same thing, and they have the same common difference. This one has a common difference of 2, this one has a common difference obviously of what? Of negative 2. Can you see? So it's quite the same sequence. So what we can do, because we are adding them, right? Because we are adding them, let's actually reverse this last term on this one, so that we can see if we can get something like 9999, right? So that we can cancel out whatever that is cancelling out, and finally get the answer. All right, so let me just put the last term here, 10,003. So because the common difference is 2, to get the next term you add 2 on the previous term, right? So if I'm reversing now, because it's an arithmetic sequence, when you reverse now, you'll just subtract what? The common difference. So I will subtract 2 then from my 10,003, so it will be 10,000 and what? And 1, right? Let me just write it properly, 10,001. If I subtract 2 again, you'll see something fantastic. It's going to be 9999. Can you see? So I can just keep it here and see how it goes, right? Can you now see that we now have something similar between the two things that we are adding, right? But the only difference is that the other one is negative, the other one is positive. So when we take this one and we add it with this one, what will happen is that 5 will cancel out with minus 5, 7 will cancel out with minus 7, obviously that 9 will cancel out with the following 9 there, right? Then 999 will cancel out with what? With 99999. Then our answer is going to what? Will be remaining with 10,001 plus 10,000 and what? And 3 plus something here, plus in this sequence here we have what? We have minus 3, right? Because we didn't have 3 there to cancel it, so it will be plus minus 3. All right, so when you add the two, it's going to give you what? 20,004 minus 3, it's going to be 20,000 and what? And 1 as the final answer. All right, or someone might have chosen to say, okay, let me just get the sum of this first sum using the sum formula, then add it with the sum of the second sum, then get the answer. All right, if you were not able to take note of the similarity between the two, and that, oh, the other one is just negative, the other one is positive. So in simple terms, you can just get the sum of this one, then you add it with the sum of this one using the sum formula. All right, otherwise that's all for me for today, grade 12. Let's meet on the next lesson. Thank you very much for joining. That's all for me, and goodbye.